Welcome back. Thanks for joining me for another video demonstration. In this demonstration, I'm going to go a little bit more in depth with Wireshark, the network analyzer that was discussed briefly in the first video demo. And the goal is to provide a little bit more functionality that you all can follow along to try and make more use of it come competition day when we start taking a look at potential network traffic that may be going to or coming from the vulnerable images that we're trying to secure. So if you haven't already done so, pause this video so that you can get the Wireshark Network Analyzer and get to this opening screen with the graphical user interface, and then from there we'll follow along. If you already have the Wireshark Network Analyzer, we're going to start with the interface list just as we had done before, and we're going to continue to operate on ETH0. I'll be scrolling a little bit more in this video because I've changed the resolution in hopes that it'll be a little bit more clear for you all. So I apologize preemptively, but we'll continue from here. ETH0 is designated by our IP address right here with the virtual machine. We're going to click Start, and just as we had done before, I'm going to minimize this and get everything continued from the previous video going again, because we're talking about backdoors. Talking about why they were dangerous, what can happen if there's a backdoor in a system, and we're going to extend some of that understanding by synthesizing the functionality aspect by getting those listeners set up so that we can continue. So everything that I'm doing here I have already done before, so I'm just kind of getting the stage set so that we can follow along and then take a look at Wireshark. So in here on this lower left hand screen, this is where I have access to the victim, and as I had done previously, I ls and it lists the contents of the directory, which I can clear. And then one of the things that I want to demonstrate in this video is the passing of traffic between an attacker and a victim. So when that happens, sometimes you get direction from Patriot in the README file to look for particular files like .txt or .jpg or .mp3. So in this particular case, we're going to pass just a simple .txt file, and then we're going to look at Wireshark to see what it looks like. So on my attacking machine, I'm actually going to set up netcat to be able to accept a file from the victim, and I do it through this command right here, nc and then -lp, which means listen on port 9999, and then take the contents and write it to this flag.file. So when I click enter or hit enter, I'm good to go to listen, and then from here I can retrieve that flag file. So I'm going to change directory. I made a new one for this video called mission objective, and I made it kind of obvious, but sometimes in capture the flag type scenarios you'll have to work for it by searching for a particular file, and the name is flag.txt. So I'm gonna retrieve this with the following command. I'm not going to break it down because it's really not something that is relevant, it's just a formality. 9999, and I want to send this file back to me. And I'm curious as to what the contents are, so I'm going to exit out of here, and I can actually go up to desktop and I can ls. Here's that flag file, and here's the message: congrats, you got the flag. Super cool. So let's stop and let's talk about this from a Wireshark standpoint. A file was transferred. Let's say the README file says, hey, be on the lookout for .txts. Start up here at the top, and just as you've done in a simple Word document or an email, Control F is your friend. It stands for find. And the default settings of Wireshark may have this button set to packet list. Change it to packet bytes. Look for .txt. I always start at the first packet and click down so to make sure I get the full effect. And if I click find right here on packet number 60, a match was found. In fact, if you right click on this highlighted packet and go up to this option called follow TCP stream, this gives you a lot of information that is much more friendly to read than at the bottom of the raw data right down here. So click follow TCP stream and a window will pop up, and you know what's pretty cool? This is the exact same window that I saw on my terminal when I was going through the victim machine. You can see all the commands that I sent. You can see the clear, you can see the ls right up here. The commands are in red, and then what was returned is in blue. And this is the pot of gold at the end of the rainbow, our flag.txt file. So one of the things I also want to demonstrate is that this Wireshark program is running on the attacking machine. Well, does it look the same if it was on the victim machine? Well, let's find out. I'm going to close this out. The little X is kind of a way for you to start all over. I'll start a new capture, clear that filter, and then what I'm going to do is close out of this flag.file, and then I'm going to set up that listener again so that I'm listening on this open port. And now we're going to do a role reversal. What was the victim is now hypothetically going to be the attacker. And the victim is going to netcat back to the attacker on that open port 9999. And the victim is kind of going to get that same hanging cursor thinking as if he's got access. So they do an ls, nothing happens. pwd, nothing happens. Change directory root, nothing happens. What's going on here? Well, I'll tell you what's going on. Do you remember that one argument that was passed, -e and then the /bin/sh? That's what's missing. So when the victim connects, they're not getting a shell right here. All they're getting is an open port. Now if that was -e /bin/sh, then they'd be able to run commands, but that's not the case. And the funny thing is the attacker who had this open port that was sending this information to flag.file, if you open that file, the funny thing is the attacker now can see all of the commands that the victim was passing to it. And you can even validate that by going into Wireshark. So let's stop this capture and let's just take it from the top. If you start with the first connection between the victim and the attacker, starts right here, .133 to 134. There was a SYN. There was an acknowledgement from us. And then there was the prepare to copy traffic. And you can go down to the next packet and see here's your ls. You can go to the next one and see pwd. In fact, if you were to just right click follow TCP stream, you might as well just get the exact same thing that was in that flag file. Isn't that cool? Just goes to show you the power of Wireshark and how important it is to be able to know what's going on in your network, know what traffic is being passed from who, and come competition day, if the README file specifies that there are things that may be passed, whether it's FTP, TFTP, or particular file extensions to be on the lookout for, this is going to be your Swiss Army knife to make that happen so that you can continue to score points, seal up vulnerabilities, and do well on the competition.